The next victim will be Vlad Paiu. He'll be talking to us about unusual and unorthodox OpenSIPS use cases, which I bet any developer in here could think that at some point or another they used it in an unorthodox way. We don't want to know about it. We just want to see the video.
It's okay? Yeah?
Yeah.
Cool. So, I'm Vlad and I'll be talking about unusual and unorthodox OpenSIPS use cases. Not be surprised, the agenda will be kind of split in half between these two. First half unusual and second half unorthodox, and there'll be pretty much tweaking with OpenSIPS and some coding as well, so just beware. I don't know. Like all of the areas we'll start with a problem sort of and converge to solutions by using OpenSIPS. First problem is, let's say we're operating a big class 4 provider. We're doing tons of traffic, maybe millions of daily minutes. We're doing A to Z traffic, so our rate sheets are probably pretty big. And we have hundreds of potentially active clients and carriers that we're using. And obviously with such big numbers, we're probably doing only postpaid. And our problem is that our existing rating engine does not really keep up with how much traffic we're doing. So on a good day, it's keeping up just fine. If we have to do any maintenance and for some whatever reason have to stop the rating engine, the engine putting prices on our CDRs, having it catch up is a pretty hard task because it's going to probably take a couple of hours for the rating engine to catch up, and in those 2 hours the network operations center will be flying in the dark because he has no clue about how's the traffic going, what's the ASR, what's the destination, and so on. And aside from trying to fix this problem of having a faster rating engine, we want to have an easy way of getting the prices for a specific client on a specific destination very easily without having to manually load up the rate sheets on the database and query the DB all the time. So we want to be able to get this information as close to real time as possible. So I was just sitting at home one day and deciding, okay, I'm just going to write an OpenSIPS module for this because it's getting kind of annoying trying to find something that's quite what I want. So I decided, okay, let's build it. And why OpenSIPS and not use any other framework? I don't know. It's basically the reasons why we all like OpenSIPS. It's very fast. It's written in C and has a good overall architecture. I'm talking here multiprocessing and all that stuff. And also it has great APIs, not necessarily from a SIP level, what I'm talking here about, but more specifically as from a developer point of view. You have shared versus private memory and variables available for you to code. You have timers, inter-process communication, and whatever. So it's fairly easy to build up some code that runs in OpenSIPS. And also very helpful for our need of having to query the module from outside is that OpenSIPS has great outer-world connectivity. So when we need to come into OpenSIPS and ask him something, we can go in via MI and query that via FIFO, MIJSON, XML RPC, whatever the standard that we like. And OpenSIPS has also great outer-world connectivity. You can do a REST query and ask a service something, or you can do SQL and NoSQL stuff fairly easy from within. So how I went ahead and implemented this was I just took the rerouting module and hacked away. The rerouting module is the one doing usually longest prefix matching and routing for certain destinations. I did no longer need a routing concept for my rating module because I just need to be able to ask the module, hey, what's the price on this destination for this call? So I just kept the prefix-based matching stuff and organized the code around the client and vendor entities that a regular, let's say, class 4 wholesale provider deals with, because carriers come and go, their rate sheets get updated, so you have to keep this engine up to date with any change that you do around either the client or the vendor. And for querying the module, is gonna just be queried via the MI interface through whatever, let's say, MI protocol you design. So in the end, the module is essentially just a list of exported MI commands that you can do via OpenSIPS CTL or Datagram or XML RPC or whatever. So you have some, let's say, API calls or MI calls where you can add a carrier, delete a carrier, reload the carrier rate that you have assigned for that carrier. And the last method is the one used for getting the carrier price for a specific destination. And I just have it here, let's say, queried in real time. So let's say if we interconnect a new carrier, host the platform, we just add it. And the module just goes to the database and loads up the info. When we assign a new rate sheet or make a change to the carrier's rate sheet, we just the module reload the rate sheet. And when we want to query the price, let's say for that carrier from a specific destination, we can just ask it the price and it returns, yeah, hey, this number matches the 4072 prefix, it's Romania Mobile Vodafone, the price is 0.009, minimum 0, increment 0, and you're billing this guy, my carrier, in USD. And the beauty of OpenSIPS is that now, having this module queryable via FIFA, you can also query it via UDP packets if you want extra speed, or you can also query it via XML RPC and get a similar reply back. So in the end, you get to an architecture similar to this. So you have a SIP server writing unrated CDRs in the format of CSV or whatever, something easily written to the SSD. Then you move those CDRs to a billing server just to keep the processing separate from your main SIP engine, where a simple rating engine just reads to the CDRs and asks our new OpenSIPS rate cacher module, hey, what's the price for this client on this source and destination number, and also give me the carrier price, and I'll just do the easy math about with minimum and increment and just write the rated CDRs in SQL and also make people copy of them. And also, since we have XML-RPC querying capabilities, we can build, let's say, a provisioning interface where the network operations center can easily query and see, okay, what's the best route on these prefix, what's the prices that we are giving to this client, what's the prices we are selling to this vendor, and so on. So it works out pretty fine, and actually it's working in production right now for a client. It's doing around 10K requests per second via UDP, which is the interconnection there with rating engine, and it's actually writing 2K requests per second to the actual database, so it's more than enough for our initial requirements. Total work is around 3,000 lines of C code, which is basically just hacking away at the routing module, so you're essentially adding limited stuff. And the OpenSIPS script does nothing because our only talk, let's say, to this module is via the FIFA engine, so we're not actually communicating via SIP, which is actually a good point, because now we're using OpenSIPS, but actually we never have it process any SIP, because we're just asking it what's the price for a given client. So we are kind of underutilizing OpenSIPS SIP capabilities, but that's no problem, because we can always add some sort of SIP commands to our rate cacher, and we can maybe ask from within the main SIP proxy and ask it, hey, I have this call from this INA to this DNS originating from this client, and these are the carriers that I have in my routing list, and I want to lose maybe 5% maximum. Should I let this call through or not? Or maybe I want to make money on this call. And we can easily script OpenSIPS to internally call our modules methods and say, okay, carrier 1 does not meet your requirements, you're going to lose more, and the only carrier you should try from a cost point of view is carrier 2. So now our module becomes even better integrated with all the entities that, let's say, our platform has. The provisioning interface, the SIP for real-time price querying, and putting the price on your actual CDRs. And of course, a nice step would be to have the main OpenSIPS actually put the price on the end CDR, because if it queries the price here for taking routing decisions, you can also put the price on calls real time. So that was, let's say, the unusual OpenSIPS use case. I've done one of them, It was done a couple, like 2-3 years ago. CG rates was not that clearly integrated, so I decided, okay, screw it, I'm gonna build my own. Now maybe it's easier to use something else. But something to keep in mind that, okay, you can do it with OpenSIPS. So moving on to using OpenSIPS to do not so simple things. I was working with some teachers sometime, and they were explicitly asking, hey, I want to do fast towards my class for clients. Because not maybe my only vendor in my route is fussing me, and instead of being the phone, maybe I want to fuss it myself and put the blame on them. Or maybe I want to mix routes, give them CLI 95% of the time, but 5% of the time give them fast. So it opens many possibilities, let's say, when operating a carrier. So I said, okay, let me build an OpenSIPS fastbox. It shouldn't be really that complicated for somebody that has a little bit of knowledge with OpenSIPS. Basically, if there's a sequential request, I just 200 OK the messages. I'm applying with the user agent server, and if there's an initial invite coming in my box, I'm just engaging a proxy. I'm saying, okay, I'll generate the PVV at 3 seconds. I just drop the request out to some fake, let's say, entity which doesn't reply to my invite messages, just so I can generate the PVV. Again, this is 111 code, I think. If I would need to finally send the 180 ringing, I just append to my reply my contact, where I can be reached and send a reply via T-reply. And if I need to actually pick up the call, I just append my contact and some SDB, depending on what first codec the initial invite that I want to fuss contains. And I just start streaming from within R3 proxy. So it's fairly simple to achieve something like this with OpenSIPS. And I just didn't know how far this can be used to do some more even worse stuff than fast. So again, same guy, same client, using the fast heavily, decides that he wants to be able to generate traffic according to some, let's say, certain rules. So he wants to be able to generate traffic, let's say, just showing an example out there, from Netherlands, Amsterdam, going to France, Orange. He wants to be able to specify some number of minutes, like, okay, I want to do 50,000 minutes a day. I wanted to have this ASR and this ACD. Of course, we want the traffic to look normal. I mean, kind of die out in the night and then grow up until peak hours and then again die down. And we want to be able to handle again a lot of it, talking about millions of generated minutes per day. And while I was, let's say, asking more about why do you need this? I mean, could we use ZP or something like that? I got to this scenario that they were targeting. So basically, you have these three carriers that sign, let's say, a backdoor agreement, where carrier X is interested in increasing his revenue. Whether this is because the account manager there is bonused on revenue, or is it because carrier X wants to, I don't know, reach some targets where they want to do a bigger revenue, doesn't really matter. So carrier A, X, and Y ensure that this loops complete. So any call going to France Orange, in my previous example, would get from A to X, then perhaps some return traffic back to Y, back to A, and the call needs to get answered. Here we have some, let's say, problems from carrier A, because it's going to have essentially two legs of the same call. It's going to generate two CDRs. It's going to be hard for him to explain the setup for billing. So essentially the call, the two CDRs must be merged, and the call has to appear as originated by carrier Y, because he's the inbound client, and terminated across carrier X. So here it was a pretty nice thing that we had the rating engine done by us, because it's kind of hard to maybe do this with other solutions. Of course, when you generate this traffic, carrier A will be the one taking the loss, because in a good world, carrier X would add an extra amount to his buying price here, and so on and so on. So carrier A is actually taking the loss by generating this traffic. But backdoor deals make it profitable, maybe because carrier X reaches his revenue target and says, hey, carrier A, have some preferential rates on some other destination. So they kind of reach a balance. It's sort of a win-win. So, I don't know, this was like sounded like a really crazy scenario. It was really weird from SIP point of view, because over here, carrier X does not, maybe can miss some calls from the loop. So if he delivers the calls to PSTN instead of to carrier Y, our dialer has to quickly end the calls, because we don't want to effectively take a loss, because we're generating traffic and somebody is actually picking up. And here, carrier Y can also send us some traffic on the same destination. So we have to say for sure, okay, this is a call I've dialed, I have to answer it, and if it's not a call I dialed, then I have to terminate it as regular business. So, and some more problems, something like Fabio was discussing, time differences, some carriers in the middle doing post-charge, so it gets crazy quite quick. So, again, what we had from the previous slides was we have a fastbox, and luckily OpenSIPS allows you to generate an invite message from DMI. The function is TUAC and DLG. So what we need is basically a dialer engine ensuring normal traffic distribution across the calls we are generating. We need an OpenSIPS scenario script to handle this, and we need to have the rating engine merging same ANI and DNS calls, because the out is CLI, because if it's not, we will not be able to differentiate and actually merge our two call legs. So in short, the solution looks like this. We have a dialer engine that daily polls, okay, how many channels do I need for this, let's say, fake dialer traffic campaign? So it's going to be 1,440 minutes a day. So if we target 10K minutes a day generated, we have to have around 8 channels a day open, on average. So if we need more channels, we just generate an ANI from the provisioned campaigns. We generated DNS, again, in my example it was France Orange. We decide if we should reject that call or not, because let's say normally looking traffic, if it has 50% ASR, then 1 in 2 calls need to be rejected. So you also have to take this into account.